Hello everyone, me and my friends are going to present an introduction to FIR Digital Filters. What is FIR Filters? In signal processing, a finite impulse response filter is a filter whose impulse response is of finite duration because it settles to zero in finite time. The impulse response of an nth order discrete time FIR filter lasts exactly n+1 samples before it settles to zero. FIR filters can be discrete time or continuous time and digital or analog. Types of FIR filters. There are various kinds of filters, namely low pass filter, high pass filter, band pass filter and band stop filter. A low pass filter allows only low frequency signals through its output, so this filter is used to eliminate high frequencies. A low pass filter is convenient for controlling the highest range of frequencies in an audio signal. An high pass filter is quite opposite to low pass filter because it rejects only frequency components below some threshold. The best example of high pass filter is cutting out the 60 Hz audible AC power, which can be selected up as noise associated almost any signal in the USA. A bandpass filter is a device that passes frequencies within a certain range and rejects frequencies outside that range. The bandstop filter is formed by the combination of low pass filter and high pass filter with the parallel connection instead of cascading connection. The name itself indicates that it will stop a particular band of frequencies. Since it eliminates high frequencies, it is also called as band elimination filter or band reject filter. Implementation of FIR filters. Digital hardware implementation. An FIR filter can be easily implemented using just 3 digital hardware elements: a multiplier, an adder, and a signal delay. Multiplier. In a DSP system, the multiplier must be fast and must have sufficient precision to support the desired application. A high quality filter will in general require more multiplications than one of lesser quality, so throughput suffers if the multiplier is not fast. Adder. Signal addition is very basic DSP function. In an FIR filter, additions are required in combination with multiplications. Hence, DSP microprocessors features multiple accumulate units. Adders generally operate with just 2 inputs at a time. Signal delay. A sample value is stored in a memory slot for one sample clock cycle and then made available as an input to the next processing stage. Software implementation. MATLAB implementation, Java implementation, and DSP implementation are the 3 software implementations. Design methods for FIR filter. An FIR filter is designed by finding the coefficients and filter order that meet certain specifications, which can be in the time domain. Designing methods of FIR filters are window design method, frequency sampling method, and optimization. Window design method. In the window design method, one first designs an ideal IIR filter and then truncates the infinite impulse response by multiplying it with a finite length window function. The result is a finite impulse response filter whose frequency response is modified from that of the IIR. If the window's main lobe is narrow, the composite frequency response remains close to that of the ideal IIR filter. Frequency sampling. The advantage of this method, we can design filters directly in the frequency domain, but the disadvantage is that sampling frequency can be only be integer times of 2 pi by n, and we cannot ensure a random cutoff frequency. Optimization. The window function method was the first method for designing linear phase FIR filters. The frequency sampling method was very popular. Lacking precise control of the specified frequencies like omega p and omega s is the most serious disadvantage of the window function method in the design of low-pass filter FIR filter. The frequency sampling method is better than the window method in the aspect that the real valued frequency response characteristics is specified, which can be either 0 or unity at all frequencies except the transition band. Frequency response of an FIR filter. The frequency response plot of the filter is shown below, where omega p is the passband ending frequency, omega s is the stop band beginning frequency, as is the amount of attenuation in the stop band. Frequencies between omega p and omega s drop in the transition band and are reduced to some lesser degree. That confirms that the filter meets the preferred specifications includes transition bandwidth, ripple, filter's length and coefficients. Advantages. They can have exactly linear phase, which refers to the condition where the phase response of the filter is a linear, that is straight line. They are always stable because all its poles are at the origin, that is for a finite input the output is always finite. The design methods are generally linear. FIR filters are non-recursive. It uses only input values and has a finite number of coefficients in the impulse response. FIR filters consume low power. And also FIR filter uses only current and past input digital samples to obtain a current output sample value. It does not utilize past output samples. Disadvantages. FIR filter require more memory, which refers to the effect of past input on the current input. Delay is more in FIR. FIR has low sensitivity, that is, FIR filter is not advanced. Also, certain responses are not practical to implement with FIR filters. FIR filters are better suited for applications that require a linear phase response. Applications. The applications of FIR filters mainly involve in digital communications in the intermediate frequency stages of the receiver. For instance, a digital radio receivers converts the analog signal to intermediate frequency and then converts it to digital using with a digital to analog converter. Then uses the finite impulse response to choose the preferred frequency. It is used in software radio, in digital receivers, in audio system. They are also used in software-defined radio and various radar applications. Conclusion and introduction to FIR digital filters have been represented. Digital filters play a vital role in various types of signal processing applications. Such filters have two important roles to play: signal separation and restoration. Following are the references. Thank you.